Okay, moving on to question 7 of the halogen derivative tutorial. We are looking at a deductive question. So in this case, we have 4 unknowns, A, B, C, D, and we're supposed to give reasons to support your answers. Now, if you have not attempted this question, I want you to stop watching this video and try to write the deductive statements on your own. Alright, recall, I said before, write down the reactions, alright, that the A and or the unknowns undergo. So over here you can see, right, 1 and 2, ethyl benzene treated with chlorine is a reaction. You can write out the reaction type of reactions. Right, so for example, A reacts with hot concentrated alcoholic potassium hydroxide. What's this reaction? A undergoes what type of reaction? And what's the deduction of the functional group that you can? So can you try to write the deductive statements first and then you run through with the solutions? Okay, so there are altogether 6 reactions that I've indicated over here. And therefore, you should be able to write at least 6 different reactions and 6 different possible deductions. Okay, so let's take a look. Ethyl benzene can be treated with chlorine to form 2 isomeric chlorides A and B under different reaction conditions. So what are the 2 possible ways ethyl benzene can react? So if you recall from your arenes, your ethyl benzene, the ethyl group can undergo FRS. C6H5, the benzene ring, can undergo electrophilic sub. So I'll write in my statement, ethyl benzene can react with chlorine to give either A and B through either free radical substitution of the ethyl side chain or electrophilic sub of the benzene ring. Okay, so you can see I write down the type of reactions. So A reacts with hot concentrated alcoholic potassium hydroxide. Hot alcoholic potassium hydroxide. This is your elimination reaction to give phenolethene. So which means A must have a Cl on the ethyl side chain. A must be a halogenoalkane. This is how you deduce A is a halogenoalkane. So, based on the positions of the chlorine can either be at position 1 or position 2, right? So it can either be 1 chloroethylbenzene or 2 chloroethylbenzene. In this case, we do not know yet. But we go on to say that, but with aqueous sodium hydroxide, it forms a secondary alcohol. So what kind of reaction with aqueous sodium hydroxide? Alright, A undergoes nucleophilic sub with aqueous sodium hydroxide to give a secondary alcohol, which means the OH must be bonded to this carbon. Alright, this carbon, because the Cl replaced with OH, then this is the carbon here, we have 2 R groups. So A itself must be a secondary halogenoalkane in order to give a secondary alcohol. And therefore, the structure of A is this, and correspondingly, the C must be with the OH at the secondary position. So you need to check for C. For C, the formula is given C8H10O, so you check the formula of C8H10O. So 8 carbons, 5 hydrogens here, and plus 5 on the ring, and then 1 oxygen. Okay? Now, moving on, we say that B is inert towards sodium hydroxide. Inert means there's no reaction. So what can we write? When we say it's inert towards reaction, we can also write a type of reaction. That means it does not undergo. Okay, so B does not undergo what kind of reaction with aqueous NaOH? So aqueous NaOH is always nucleophilic sub, right? So it's inert towards nucleophilic sub. That means it does not. Okay, I just change it up. Does not undergo nucleophilic sub with aqueous NaOH. So what must B be? B cannot be a halogenoalkane. It must be a halogenoarene. Okay, so this is the red statements are all the functional groups which I've deduced along the way. This is the harder one. The one I expect you guys to be able to write is all the various types of reactions. Okay, moving on to 6, but it's oxidized by aqueous potassium manganate to form an acid. Okay, so type of reaction with KMnO4 is oxidation, right? Because KMnO4 is a common oxidizing agent. You'll notice that from 8 carbons, it has decreased to now 7 carbons, which means that it has only 1 side chain, and D must be a monocarboxylic acid. How do I know it's a monocarboxylic acid? Based on the molecular formula, there are 2 oxygen, and I know that when there's a side chain, alright, it will become a COOH. So one COOH will have 2 O's. Since there's only 2 O's, that means there's only 1 carboxylic acid group. So B could be, alright, in the 1,2 position, ethyl with a chloro position. Alright, but take note, in this case, it can also be the 1,4 position because you start off with ethyl benzene. Alright, remember you start off with ethyl benzene and you do electrophilic sub. So ethyl benzene, position 1, position 2, or position 4. Whereas ethyl group, it's a 2,4 director. Okay, but the 3 position one is not likely because, as I said, ethyl group is 2,4 directing. And D, corresponding, if you oxidize this CH2, CH3 becomes COOH. And you can check the molecular formula. Alright, you check the molecular formula, whether it fulfills the requirement. Can so far? So that's question 7. So that's one way you systematically do to get the structure. Alternatively, if it's more complicated, you may also consider using a flow chart. So basically this flow chart that you see in the suggested solution, it's my way of trying to see if everything makes sense. Okay, so you can use this to supplement your learning. Okay, that's question 7.